Let's look at solving trig equations. For example, let's solve this equation here, but only on the interval 0 to 2 pi. We can begin by subtracting 3 from both sides of this equation, which would give us 2 times sine of theta is equal to -1. And now dividing both sides by 2 gives us that sine of theta is equal to -1/2. So we need to find all angles theta in this interval here, 0 to 2 pi, that have sine equal to -1/2. Well, let's recall our unit circle. Remember that the sine is the y-coordinate of the point of intersection of the terminal side of the angle and the unit circle. So looking down here in quadrant 3, we see that the y-coordinate of this point is -1/2, which corresponds to the angle of 7 pi divided by 6. But also over here in quadrant 4, the y-coordinate of this point is also -1/2, which corresponds to the angle of 11 pi divided by 6. Therefore, the sine of both of these angles will equal -1/2. Which means our answer here then is theta is equal to 7 pi divided by 6 or 11 pi divided by 6. All right, let's look at another example. Again, let's solve this equation only on the interval 0 to 2 pi. We can begin by subtracting 2 from both sides, which gives us secant of theta is equal to -2. Now remember that secant of theta is equal to 1 divided by cosine of theta, or cosine of theta is equal to 1 divided by secant of theta. And therefore, if secant of theta is equal to -2, then we're looking for angles theta such that cosine of theta is 1 divided by -2, or -1/2. Again, recalling our unit circle, and remembering that the cosine of theta is the x-coordinate of the point of intersection of the terminal side of the angle and the unit circle. We see that the x-coordinate of this point here in quadrant 2 is -1/2, which corresponds to the angle of 2 pi divided by 3. But also down here in quadrant 3, the x-coordinate of this point is also -1/2, which corresponds to the angle of 4 pi divided by 3. Therefore, our answer here would be theta is equal to 2 pi divided by 3, or 4 pi divided by 3. All right, let's look at one more example. Again, let's find all solutions to this equation, but only in the interval 0 to 2 pi. We'll begin by adding 1 to both sides, which gives us cotangent of theta is equal to 1. Now remember that cotangent of theta is equal to cosine of theta divided by sine of theta. But we just saw that the cosine of theta was the x-coordinate of the point of intersection of the terminal side of the angle and the unit circle, and the sine of theta was the y-coordinate. So this would be equal to x divided by y. So therefore, we are looking for angles in the interval 0 to 2 pi where this ratio of x to y is equal to 1. And this will happen at pi over 4 as well as 5 pi over 4. Because remember our unit circle. At pi over 4, the ratio of x to y here will be equal to 1. But also down here in quadrant 3, the ratio of x to y will also equal 1, which corresponds to the angle of 5 pi divided by 4. And don't forget this angle down here in quadrant 3. Most students will only remember the angle in quadrant 1, But the ratio of x to y in quadrant 3 will also yield a positive number. Therefore, our answer here is theta is equal to pi divided by 4 or 5 pi divided by 4. And this is how we solve trigonometric equations on this interval 0 to 2 pi. Thank you, and we'll see you next time.